So, is that for what's coming out of from the cutting process?
Yeah.
I really should wear goggles. Well, thanks. So that's kind of neat already to see that there's a certain shape happening just from the configuration of a few simple bricks, right? That's kind of, yeah.
With the rocket mass, you basically split what you're doing right now to make it circle around.
Right, so that, yeah, that was exactly where I wanted to go. So, an important idea, we talked about the efficiency of a fire being directly related to how hot the fire is, right? So if you think about in a wood stove, the same chamber that burns the fire also emits the heat. And so it can only get so hot because it's losing heat. A rocket mass heater, and I think another reason why rocket mass heaters have been so exciting, is that they really demonstrate the idea that first you want to turn the wood into heat through as efficient combustion as possible, and you actually want to isolate that from then how you capture the heat. So, and in general, I'd call that the thermal battery. And rocket mass heaters are kind of cool because they have they have some quick heat from the metal surface of the barrel, and then more retained heat. And I should apologize, actually, that some of you guys might not really know much about rocket mass heaters, and I'm already getting in deeper. But what we're going to be seeing here is a combustion box that in a rocket mass heater often then has a barrel that the smoke goes down the barrel and then through a pipe that usually has cob in it that retains more of the heat. So after the fire goes out, that bench might still be warm for like another day or even two, depending on how it's built. So one interesting thing is, I'm going to see, we'll just see what the effect of adding stack, if we can get this fire backlit, just pretty smoky right now, right? We're going to try to get rid of completely of that. I'm trying to speed the airflow up enough without blowing on it to, I think it's getting there.
Will a taller chimney create more draw?
Yeah.
Generally?
Yeah. Draw is relationship. Yeah. It's actually, those of you who would like, it might make more sense to sit a little bit further over there. So yeah, that's a great question. So draw is a relationship between the height of a chimney and the temperature of the chimney. So that's another thing that rocket mass heaters have kind of helped us understand, is that whereas the tall chimneys on fireplaces are necessary to get that draft going, you can achieve to some degree like a similar draft by having a shorter chimney that's really hot. So if we were to continue to build this up, I'm doing this kind of casually, but something that I'm hoping to share with you guys over the next couple of days that kind of requires a deep, just entering into, for example, the world of bricks is really, you know, understanding how what shapes will help the bricks fit together best, right? So in rocket mass heaters, there's this notion in the heat riser where you have this kind of like helicoptering of the bricks so that your bond is changing on each subsequent course, and do you guys kind of see that, how on each course it's switching, or you could say that it's kind of spiraling up? So yeah, you can tell we got a lively, we got some good sound there, right? It should get better and better, really. Just for fun, I think I'm gonna build up a couple. Yeah, please check it out. You want to see it on the inside? Yeah. Yeah. Check out how, as I build the chimney up, how much it's really drawing the flames up. Yeah. And check out how like it's tugging against certain corners, and there's like spirals within spirals.
Does it hug closer to the bricks that are hotter?
Well, it has to do with that, but it also has to do with shape. Just that it's hitting that back wall. So, yeah, we're gonna stick some more glue on there. So at our house we have two different stoves. We have one big canning stove for doing like big hot water baths or making big batches of wheat paste for plaster, where it's not too different from this, but then we have a way to hold the pots, to stand the pots. Actually, we kind of want to show you guys. Just hold on one second. One of the simplest, easiest projects you can do, this will be, everyone's had a chance who wants to see, is like a wok burner. It's a really fun outdoor cooking thing where you just take down a number of courses, and you might make your firebox one more course high. I can't emphasize. There's two things that I did casually that are really important if you want to replicate something like this, and this has to do with that notion of like you guys being able to carry this home. Just that this spacing is just enough so that you can bridge something. And in this case, I chose to lay these on their bed, and these what would be called shiners, just sitting on their sides. And that gives me a nice relationship of height and width. It's not quite square, but it just so happens in rocket mass heaters that almost always is the best way to do it. You just have one on the bed and one shiner. So if I brought this down a couple courses, I was going to get, there's a round piece of ceramic glass that can go in the cooktop that Rob and Mallory are going to have. And it's kind of fun to put that on top and watch the flames. But I think I really want to respect that it's like their project, and I want to deliver their things unused. So, but anyway, so at home we do these yakisoba parties, and sometimes we call them yakisoba parties because we have a basketball court. And so, you know, basically by having like that and, you know, a little bit more fuel, you get usually one less course.
It totally lost its rocket down. That last course you took off.
Yeah, huh?
Took off again.
Yeah. So we should put it back on. You're really right. So, yeah, this is the wok burner. And you put your wok right there, and it's just really fun. Okay, so this is only part of the rocket mass here. We're going to explore what we've been exploring so far is the basic notion of a rocket stove, which is a short, hot heat riser tends to create good dynamic combustion, and then you transfer that to some sort of cooking implement. If these bricks were insulated, right now a lot of the heat from the fire is going into heating up those bricks. If those bricks were insulated, the draft would be a lot better and a lot more of the heat would be getting up to the top. Right? So there are insulative kiln brick that can be used. Yeah. Yeah.
So there are two things that we need to keep in mind that you did casually here that we need to,
Yeah.
if we want to recreate it, then we need to remember it. I only got it.
Okay, which one did you get?
I got, basically the opening should be just wide enough, and I stopped there because I don't know if it's finished. And then shiners, and then one on bed, and one sit down and one shiner.
Yeah.
It's like a pretty good ratio generally.
Yeah.
So that's all I got.
Yeah. Okay, so just come look at this brick, and that'll pretty much say the whole story on the spacing. And actually, it'll become more clear now. And actually, so check this out. You just segued into the. So, you know what happens. So that notion is so that this width is just wide enough so that you can still. If these were wider apart, we wouldn't have any way to cover that, and no way to support this chimney here.
What was the second thing?
He's also breaking up. He was talking about breaking his joints or not having it like so they're staggered.
I got that, but that came after the two things, and I just want to make sure that I got the two things, and if that's it, then I wanted to just be sure that that's it.
Yeah. The second thing was this bed and then shiner. I wonder,
the bridge
Fawn,
and
would
the
you
shiner.
grab
Okay,
some fire brick? There's some fire brick over there. Oh, perfect. Yeah. Could you bring a couple more over? If you wanted to, yeah, you could use these. Have you used these?
Yeah.
You might have to set them. So, if we were doing this with fire brick, which it's often done, this is what the bed and then the shiner would look like. And then when we spaced out our width, which we will do, we would just make sure that we were able to bridge across there. Yeah, we can come. Let's come back to the notion of cross-sectional area. You guys can remind me to get back to that. Okay. So get rid of the wok burner. In the canning stove that we have, then I built up a round wall so that the pot sits in and there's just a real narrow space that the fire kind of hugs the pot. Okay, so one thing that Yanto Evans and Leslie Jackson co-authored the book Rocket Mass Heaters. Is he like basically turn the fire upside down, and hopefully I'll be able to demonstrate what I mean by that. Okay. So, fire's kind of doing its thing, not too exciting. If we were to put more bricks back up here, it'd probably pick back up, right? Okay, so I'm going to try to confuse the fire.
Have enough fuel?
What's that?
Does it still have enough fuel?
Yeah, we could give it some more. We could give it some more, and we could even help it pick up a little bit. I was wondering why I was coughing, and then I realized that there was smoke going straight at me.
So is this the size of fuel that you would want to use when it's built in the home?
Well, that's a great question. I'm using it partly to keep the fire small, but that's one thing about rocket mass heaters is they require, in general, pretty fine stuff. Like, your fuel can be bigger than this once you're going, but you do need to chop your wood down further, or more than for other stoves. And cool. Wow, those are really nice brick. Yeah. So it can be quite a bit bigger, but not that big. And you could say that what we're going to be building is more what's called a batch style rocket, where you can put quite a bit of larger fuel in and not have to tend it as much. Okay, so put in a little bit more just for fun. So one interesting thing would be to like basically create a competing chimney.
Yeah.
So I'm going to try to get back. I could cut this brick, that would make it easier, but so here I'm going to get back to our spiral. In order to do that, one brick goes past. Does anyone have an idea, just anticipate what's going to happen if I keep building this up?
And once the draft gets too hard, then it's going to start flowing that way, right?
Yeah, but there's that whole temperature thing, right? Like this chimney's lower, but it's hotter.
Smoke will be going out that way. The smoke will be trying to go the other way.
Gotta have an intake. I feel like it'll keep drawing in through that until you do something to change the direction, and then it'll want to go the other way once that starts to get heated.
But see, right now they're pretty equal, so right now it's faltering a little bit, and now it chose to go back there, right? And then as we build this up, yeah, so you're exactly right. It needs a reason. Also, this system's not sealed, so these aren't the only two possibilities. There's air coming in, but and that's my magic trick for the day. So basically what we've got here, if you were to take a picture of it or draw it, is like exactly the drawing in the Rocket Mass heater book. Like if you paid attention and you kind of understand this and now you tried to replicate it, like the best thing that we could do, and something that to some degree is going to be up to you guys over, like tomorrow we're really going to get into our project over there, and I'm going to be doing a lot of demonstrating. This afternoon we're going to be doing a lot of preparation, and then starting Wednesday there'll be some space for those of you who like want to take the initiative to practice bricklaying or to from scratch put this together, just to make sure that you have that knowledge, that you can do it. One kind of fun thing too is to so this is how you put fuel into a Rocket Mass heater, and pretty soon you'll see generally how it burns, which is at the tips, which is kind of neat. When we were talking about like when you add cold fuel on top of a fire, you get a lot of pollution. Well, in this case, you're almost never adding fuel on top of the fire.
Oh, yeah.
And it's feeding itself down into the hottest part of the fire, just kind of as needs be. And like even more specifically, so come check out, come take a look just at what's going on, like get a visual on that, and we'll put a couple. I'll put a few more bricks on it. Oh, hold it. So that sound that we're hearing is what gives rockets their name too. And it's kind of fun to just like watch it from that perspective too. You can see that when I removed this brick, it created a little bit of back pressure.
Back pressure.
Yeah, it was more tendency. So this little bit of smoke, that is the nightmare of Rocket Mass heaters. They can be finicky, and especially when you then put a barrel over this and you create a whole run before it then gets up a chimney. There can be a lot of pressure to compete. In our case, this is happening mainly because this isn't sealed. Like if it's sealed, then there's really just one direction for things to go. Yeah, so one thing I'm thinking about is like later in the week we'll probably do a tour of the rocket, the different things that we've done in past years, and you'll know that this is what's inside some of the barrels that you'll see, and you'll see this pattern right here replicated.
With the Rocket Mass heater, I know that for this one we started over here and then built the side up, and you're normally feeding in this way because you don't have that opening once it's already built. Won't the flames start coming up originally?
Like how do you start one?
Yeah.
Yeah, so starting them is interesting and tricky, and what you need to do is you prepare like 3 or 4 pieces of paper, and perhaps we'll do this. I don't know that we'll actually do this, so it's good that I talk about it. And you light one piece of paper and you reach in there and you try to get it as close to underneath that chimney, and you try to create the draft of this chimney, and then you put the next piece of paper just behind it, and you basically track it back to a whole bunch of fine kindling. And again, these are examples of why the Rocket Mass heater, despite its internet fame, has a lot of has challenges. And so what we'll be doing at Robin Mal's is like an evolution of that, where we're going to be This is called a downdraft firebox, or a downdraft